this chapter, I want to illustrate how we break down a visualization, and therefore we will talk about marks and channels. Marks and channels are something that we implicitly use, but now we also want to explicitly think about them. In this picture we see a bar chart, but what are its parts? Pause the video now and think about how you would create this picture in a drawing program. So if you think about these parts of this bar chart and how you would do this in a drawing program, I for one would start with two lines that represent the axes, x and the y axis. And then I would draw some rectangles. These are my bars. These rectangles, to make them easier to distinguish them, they would get a color. Then I can use text to indicate a label, whether it's on the y-axis, it shows me the value of the height of the rectangle, or on the x-axis, where this is actually a category, it shows me to which category this rectangle belongs. And then we also have the height of these rectangles, where the height encodes a value, and the width of the rectangle, which in this case is just chosen so that every rectangle has the same width and it fills the whole space. Marks are the basic graphical elements that we are using, so they are the geometric primitives. They start at 0 dimensions, which are simple points, and then we can go up in dimensionality, starting with lines, areas for 2D, and even volumes for 3D. And the channels, they control the appearances of the mark. So appearance can be the position of a mark, either horizontal, vertical, or even both. Can be the size, which can be, depending on which mark we are talking about, either the length of a line, the area of a point, or in this example a rectangle, or even the volume. The shape is also a thing that we can distinguish. The orientation, and here in the example I have the tilt of this line, or the color. And color can be broken down into 3 different aspects, which is the hue, saturation, and the lightness. Here we can see the marks and channels that are used in Polaris. Polaris is a visualization tool for multidimensional relational databases, and it can be sometimes seen as Tableau Senior, the predecessor to Tableau in some senses. Here we have a handy map of the property, the marks that are used with these properties, and their mappings in the ordinal and in the quantitative space. The first property is shape. The mark is a glyph, and we can see the different glyphs that are available in Polaris. They are used to show some ordinal or nominal mapping. And there is no way with glyphs that we can usefully show a quantitative map. The size of different marks, whether they are rectangles, circles, glyphs, or text, can be used either ordinal or quantitative, where in ordinal we have to make sure that there is equal spacing between the different orders, and we can clearly distinguish the orders, whereas the quantitative mapping, it's a fluid scale. The same is true for orientation. Here we can orient our lines. If we have very clear orientation, we can use this for ordinal mappings. And if it's a continuous angle that we're using, we can use that for quantitative mapping. And last but not least, the color. Color can be used in every single mark that is available. And it can be used when we just choose a different hue or ordinal mappings, or we use a color scale. In this sense, we then know the more gray the color is, the less the value is, and the higher the value gets, the more reddish it gets. So this again is a continuous scale for the quantitative mapping. These channels also have different expressiveness types and effectiveness ranks. So for example, we have the magnitude channel for ordered attributes. And here in this list, you can see their effectiveness ranked from the most effective on the top to the least effective on the bottom. So for ordered attributes, if we choose a position on a common scale, so the scale is the same size, and we choose the position of 2 dots, we can easily compare those positions, and therefore it's a very effective channel for ordered attributes. The second most effective is the position on an unaligned scale. So even if those scales are unaligned and they don't even have to be the same length, we can easily compare the position on an unaligned scale as well. The next most effective is length, so the one-dimensional size. Then comes the tilt. Be aware that area is less effective than tilt. You might wonder, because tilt is already somewhat ineffective. But that's the case because the human brain is very bad at understanding areas and judging areas. Depth is also very hard for us because on a two-dimensional monitor, it's hard to actually see depth. And then there comes the color luminance and saturation, which is equally bad to show order. And the curvature and volume is the least effective for ordered attributes. And in the identity channel, we are talking about the categorical attributes. So if you want to have marks appear in different categories, the channel of spatial region is the most effective. The second most effective is color, and in this case it's the hue. Then we have motion, which is also somewhat effective. And the least effective in this case is the shape. We can also make use of another perceptional property, which is the pop-out, or also called the pre-attentive processing. If we look at this sample image, we can immediately spot the highlighted dot, because it has a different color than all the other dots in that image. This is still the case if we're looking at an image with a lot of dots and one is highlighted. But be aware, as soon as I don't use color for this pop-out, but instead I now use the shape of the glyph, it's much harder to spot the one in contrast to the other two images. And if I then go along and use color and the shape, and I still want to achieve the effect of pop-out, I'm pretty sure by now almost nobody has found the one that stands out in this image. Here you can see for yourself how long it takes you to recognize every single object that is different, and thus get an idea on how well a certain channel works for drawing your audience's attention towards a certain object. To give you the solution to these, in the top left image, it is the tilt. Top center is the size of the object, And in the top right, it is the shape. On the bottom left, it is the density, which achieves the pop-out effect. In the bottom center, one of the shadows is different. And in the bottom right, one of those glyphs uses parallel lines, whereas all the others have tilted lines. And finally, I want to show you some examples of expressiveness and effectiveness. The expressiveness principle states visual encoding should express all of and only the information in the dataset attributes. So you must not add information that does not exist. And another thing for expressiveness is also the lie factor. And for this, I have an example here. This graphic wants to show the fuel economy standards and how they changed. So they are plotting it on a road because that's visually appealing to the car drivers. And the line in the back represents the fuel economy standard in 1978, which is 18 miles per gallon and is 0.6 inches long. And then the line in the front in 1985 represents 27.5 miles per gallon, but it is 5.3 inches long. So it is way over-representing in terms of the length of the size what the actual data is. Obviously, the author of this graphic wanted to make it look in that fashion, because obviously that's a graphic that has been published by a car manufacturer. And the effectiveness principle says the importance of the attribute should also match the salience of the channel. So the more important the mark is, the more important channel it should get. Also, always keep in mind your data ink ratio. The data ink ratio states that you should use as least ink as possible to display your data. So if you look at the example, there is a lot of ink used if you think on how you would draw that on paper. And we can simply reduce the ink in a fashion that still the same data is shown, but I use way less ink and therefore I'm way less distracted by the background, the unnecessary grid in the graphic, and so on. And with all that information in mind, let's now head into Tableau. Let us revisit the visualization of the happiness score by region again to see how different marks and channels affect it. For this, we will create a new sheet again, put the happiness score in the columns and the map reference in the rows section. Again, we want the average happiness here, and we will sort by the map reference again. We can now apply different marks to this visualization. We could do this by using this marks field here, but it is way easier to let Tableau do the hard work by clicking in the top right corner here on the Show Me button. You see what different visualizations are possible. It also gives you an information on what dimensions or measures you need for a given visualization, and it highlights the ones that are possible right now. So let's just switch from the mark length to area and create a tree map. You can now see that the columns and rows are empty, and Tableau automatically put those values into our marks channel. So now we have the average happiness score in the size channel. We also have average happiness as color. And we have the map reference as text channel plotted on each mark. Since the average happiness score is now encoded in two different kinds, namely the size and the color, we can use one of those to encode a different information. So let's encode the population with size. We now get an overview of how big the different regions are, and the color shows us the happiness of the regions. We can now revert this visualization back into bar charts by clicking the Show Me button again and selecting the bars. You can see that it now creates two different sets of bar charts. One set of bar chart has the average happiness score, and the other one is the population. We can now manually unify those two by setting the average happiness score into the color channel. And now we only have one set of bars that are color coded by the happiness. Since those colors are all pretty similar, we can go into the color channel, click Edit Colors, and change the palette. And for this, I like to use the green gold palette because it starts in the gold and then quickly turns into green. So we have a broad spectrum of the high values, whereas the low values are immediately visible in gold. Just click OK to select it, and now you can see the happiness encoded in green and gold. Now let's finally give this sheet a name. And we have created another visualization. Let's follow this up with a new idea. And this new idea is, how are the Gini coefficient, the GDP, and happiness related by country? So we will pull the Gini coefficient into the columns section, and we pull the GDP per capita into the row section. We again get a scatter plot with a single dot because it is the sum of all Gini coefficients and the sum of all GDPs, since Tableau thinks that these are two measures. But for this, if we want to compare them individually, we want to change those into dimensions. So we just click on the little arrow or right click on those and then change the dimension. We also do this for the second one. And now we get a scatter plot. We can change the shape to filled circles to more easily see the circles. And if we want to see what countries we are looking at, we can just pull them into the label section and the countries get labeled. In order to relate those data to the happiness score, we now drag the happiness score into the color mark, and we can now see the happiness score in the color channel. We still have another channel left that we can use, so we can drag the human development index into the size channel, and we immediately see all the dots updated and their size representing the human development index of the country. But be aware when you do that, Tableau assumes something about the data because it doesn't know what the data actually is. So it sets standardized range. It tries to automatically detect the range of the values. So it might be necessary that we edit the size ourselves. For this, we go into Edit Sizes, and we can say that we want to have a range of values, and we start our value. Since the Human Development Index starts at 0, we start at 0, and the max Human Development Index that could be reached is 1. So we therefore set the range between 0 and 1. So the sizes are better represented. Another thing that's currently happening in this dataset is the higher the Gini coefficient is, the worse the inequality gets. So a very low Gini coefficient is a high equality in income, but we are used to seeing the best scoring marks at the right and the lowest scores at the left. So we can just right click on the bottom axis, edit the axis, and set the scale to reversed in order to represent that the best scoring country is actually Azerbaijan. We saw in the presentation that color can be used for ordinal and for categorical data. So we can change the color in such a fashion that it actually becomes categorical. We do this by clicking onto the color mark and then edit colors. And we can introduce stepping. And let's step it quarterly. So we now have the full range of happiness scores, but they are quartered evenly. So we have the lowest quarter in this light blue and the highest quarter in this dark blue shade. If we click OK, we can see the groups of colors more clearly than before. With this, we can now easily spot that all the very low ranking GDPs also have a very low happiness score, but the rest of the happiness score is across all different GDPs. So only the very low GDP is responsible for a very low happiness score. We can also see that for Botswana, which has a higher GDP than the average very low scoring happiness score, it has a very high Gini index, so the inequality is very high. So therefore we can also conclude that the very high Gini index negatively affects the happiness, even though the GDP might be higher. Another thing that we can see is that there are some values missing. This is indicated by this 35 nulls field down here. And those null values are values which do not have a Gini coefficient in the dataset. So be aware when looking at this that there are still some countries missing. We can click on that and have Tableau auto-create a filter, but there's no need to do that right now, because in this case it is better to have the indication that there is null values as well than to just filter them out. Finally, let's rename the sheet. And save it.